Okay, some of you mentioned that you're having a hard time with problems 11 through 15 because we didn't really get to talk in detail about work in class. So I'll go ahead and give you hints for each of the problems. So rather than just taking out the problems entirely from this homework, let's see if we can get you to a point where you can approach all of them. So these are the two main equations that I mentioned in class. So if the force is constant over some displacement, we calculate work. Also, I should not have a vector on top of work. Work is a scalar quantity. We calculate how much work is done by doing a dot product between the force and the displacement vector. And that dot product can be written as the magnitude of the force vector times the magnitude of the displacement vector times cosine of the angle between the two. So if this is what the force vector looks like and this is what delta x is, this is how you're moving the object, then this is the angle theta. So for example, if the force points this way to the right in delta x, meaning you're moving the object to the left, that way the angle between them would be 180 degrees. Another example is forces to the right, delta x is also to the right. Well, in that case, the two are parallel to each other, so theta here is 0 degrees. So keeping that in mind, let's give these problems a try. So part A of problem 11 is actually something you should be able to do in terms of quiz material, which is this man is pushing on this piano as the piano slides down, and the man's push is keeping the piano from accelerating. So basically, it's moving down with some constant velocity, and we're told that it moves and slides down a distance of 3.9 meters. So for part A, you're being asked to find how hard does the man have to push in order to keep the piano from accelerating, and you should get the answer 1700 newtons. And I've given you a big hint. This is what the free body diagram of this situation looks like. Okay, once you figure that out, let's work on part B together. The work done by the man on the piano. So work done by this person pushing the man on the piano is going to be the force that the person pushes with dotted into the displacement vector of how much the piano slides. So we know, if we look at this picture here, the person is pushing up the ramp. That's the direction of P. The piano is sliding down the ramp. If we take a look at the two vectors, there's an angle of 180 degrees between them. So theta in this case is 180 degrees. So the way we write this is the magnitude of the force that the person pushes with times the magnitude of the displacement times cosine of 180 degrees. And for the force that the person pushes with is 1700 newtons. The displacement that the piano slides down is 3.9 meters, and you multiply by cosine of 180. What you'll notice is you're getting a negative overall number here. What that's saying is this man is doing negative work on the system, basically taking away some of the energy to slow it down as it slides down. Because if the man moves out of the way, the piano accelerates down the ramp and gets faster and faster. The man is doing negative work and keeping it from accelerating, taking some of that energy away. We'll talk more in detail about what positive and negative work means. This is just to bring to your attention. Okay, then part C says the work done by the force of gravity. Well, the work done by the force of gravity is going to be force of gravity is force of gravity dotted into the displacement again. So now we take a look at those two vectors. Well, we know force of gravity points downward like this. So there's Fg. And we know the displacement from previous part, it slides this way. So we need to figure out what this angle is. Let me just move things a little bit so that I can maybe ask you this again. So if this is what the two vectors look like, let me move the plane there. We know this angle is given to us. This theta down here, we know this is 90 degrees. We know this is 90 minus theta. And I think theta is given to us as 27 degrees. So if this is 27 degrees, we do 90 minus 27. And we get that this angle is 63 degrees. So the angle between force of gravity vector So between the force of gravity vector and displacement vector is 63 degrees. So we write this as the magnitude of force of gravity, which is just mg, times the magnitude of the displacement vector, which we know from before is 3.9, times cosine of 63 degrees. And you can go ahead and calculate this one. And then I'll just give you a hint for the last one. The last one is the net work done on the piano. Well, we just found the work done by the force that the person pushes with. We found the work done by gravity. We have not yet found the work done by the normal force. Now here's something nice. The normal force, let's redraw the situation. So the normal force points in this direction, Fn. Displacement points in this direction, delta x. The angle between them is 90 degrees. Well, if we calculate the work done by the normal force, we're going to get Fn dotted into delta x, which is the magnitude of Fn, times the magnitude of delta x, times the cosine of the angle between them. And the angle between them is 90 degrees. Well, cosine of 90 degrees, if you remember from your unit circle, is 0. So it doesn't matter what this product is, because because the force is perpendicular to the displacement, normal force does no work on this piano. So whenever you have a force that's perpendicular to the displacement, work done by it is 0. So to find the net work done by all the forces on the piano, you would add the work done by the person to the work done by gravity, and you get the answer. So this should give you more than enough to work with for problem 11.